Yes.
Okay, so so my talk on crop residue upon burning and effect on air quality. Now I will ask Anju to show 3 minutes video, please. Can you hear?
Maybe sound is not there.
The sound not there.
Oh, yeah. Maybe Anju, you can just increase the volume.
Can you see the YouTube screen?
Yes, increase the volume and show the full screen.
Can you just go to the
แต่ละแปลงจะเกี่ยวไม่พร้อมกันมันจะมีวันแค่ไม่นานประมาณสักครึ่งชั่วโมงหนึ่งก็แต่เราลองทำแล้วที่ย่อยพอเราตีไปปุ๊บเนี่ยเราต้องรีบทำเลยใช่ไหมอันนี้มันจะเกิดที่นี่นะปลามันจะได้
Burning rice straw actually have less effect to air quality, to the human health, and to the crop, and at the same time also to the climate.
So say no to rice straw open burning.
Okay, thank you. Thank you. Can we stop it there? Thank you. Okay, let me start my screen sharing. So you see my screen now?
Not yet.
Not yet. Okay. Okay.
Yeah.
Is it see?
Yes, now we can able to see.
Okay. Okay. So the video also short, but actually also capture the key message that I would like to convey. So now looking at this, so I just tried to get it from the NASA website a couple of days ago and say open burning, where and when. So we can see here the picture of global, right? In January this year, so we see a lot of open burning over Southeast Asia, India, and all over Asia. So May, also a lot of open burning, and November also. So it means that here we burn everywhere and also anytime. So a lot of open burning. And the hot spot here, it represents forest fire or crop residue burning or other kind of open burning. So content of my talk, I give an overview of air quality in Asia. And the second part is crop residue open burning and emission. And then followed by crop residue open burning, effect on air quality, and then non-open burning alternatives. So let's talk about the air pollution. So air pollution, we normally think of the cause and effect links. The cause, of course, the emission. So we have emission from cooking, from forest fire, from industry, from natural sources, from traffic. And then once emitted, the pollutant are mixed in the air, up and down, back and forth, and transported by wind and establish certain level in ambient air. We call it ambient concentration. And depend on the level in the air, we will see the effect on human health, on ecosystem, and atmosphere, like this is a picture of atmospheric ground clouds, and of course, climate. Now talking about air pollution in Asia. So here we see very high level of ambient air pollution. And the most important pollutant will have particulate matters. So we call here PMX, including different sizes like PM10, PM2.5, the TSP stands for total suspended particulate matter. And we talk about PM1, we talk about ultrafine and nanoparticles in the air. So at present, PM2.5 is key regulated pollutants. So, and of great interest because of Haze problem. So we have gaseous pollutant like CO and sulfur oxide, but it's good news that the level are declining in the air, while some other gases like NOx and ozone are increasing. So also the level of toxic air pollutants like volatile organic compounds like benzene, for example, semi-volatile organic compounds like dioxin, like PHGs, and a lot of heavy metals also present in air, but we do not have very good like quantification of the level of these pollutants yet. In terms of emissions, the source emission increased very fast in terms of intensity and number of sources, bypassing control efforts. That's why you can see that level of pollution in ambient air in many countries actually increasing with time. The impact on human health and crop and ecosystem are serious. However, they're not very well quantified because we need a lot of studies to do that. And we have serious indoor air pollution problems from the cooking, smoking indoor, for example. In addition, we also have transboundary and long-range transport, like acid rains, atmospheric ground clouds, actually first over the Indian Ocean actually discovered, and now it become very familiar terms. Regional haze caused by forest fire, dust storm, so this is the problem. And perhaps it's not all, but there's a key problem in Asia. So in terms of level of pollution, okay. Talking about PM, so PM is very important pollutants I mentioned earlier, and it have different terminology, like we have the TSP, It's all the particles suspended in the air and that is captured by high volume sampler. And normally with the size below 20 to 50 micron, depend on the density of particle. And PM10 is everything 10 and below. And PM2.5 is everything 2.5 and below. Okay. And then we also have the ultrafine particles, that is everything lesser than 0.1 micron or 100 nanometers, and nanoparticles is lesser than 50 nanometers. The smaller particles are more toxic because smaller particles can get deep in our respiratory system. So like PM10 can get into our lung. PM above 10 micron, normally our body would prevent it from entering our body. So, and then we have, if we have lower, smaller particles like PM2.5 get deep into our body, and then nanoparticles actually can be found in the brain, actually can get very deep inside. The haze in Asia actually very intense. So this is a picture showing Bangkok in January 2019, last year. Huge episodes. It caused a lot of concern from public and authority. So in India, nowadays, actually I downloaded a few days ago, and that is showing picture of Delhi. And in Beijing, actually a couple of years ago. Okay. So overall in Asia, PM level is very high. As you can see here, this is from the UNEP Clean Air Solution Report that released last year. And this is ambient PM level in 2015. And you can see dark color here where the level is above 100 micrograms per cubic meters. And then we call it the population weighted concentration level. And you can see here over India and China, so we see a lot of darker color here showing high level. And in fact, 90% of people in Asia breathing PM air quality exceeding WHO guidelines. It guidelines 10 micron per cubic meter annual level. So that's why we need to quantify the effects and analyze measures to provide science-based recommendations to policy recommendations. So this is one of the important tasks of the research institution and like group at CEPHA. So the PM pollution in Asia and health risks. So we talk about many studies recently by WHO for more recent year, but I quote here a peer review research that it talks about deaths attributed to PM pollution in 2015. And you can see this darker color here, more people die. Okay? More people die in this area. So globally, ambient PM 2.5 caused 4.2 million deaths. Okay? And 103 million Dalis. Dalis for stay for disability adjusted life year loss. It means that we are sick, then we also could not work, so it also counted like the loss of our time. So, and then it ranked 5th for mortality risk factor by Cohen et al. Okay, that is. And the highest death rates you can see it observed over Asia, India, China, so and other countries in Asia. So talking about the sources, so we have many sources. So we have open burning of crop residue in Thailand, in Vietnam. So this is solid waste, open burning in Laos, forest fire, backyard open burning, so cooking, the emission from the food and from the fuel, incense burning, smoking, and in terms of big source, we also have transport pollution, we have industry, we have weekends, we have road dust, etc. So we have huge amount of sources. And today we talk about open burning of crop residues. So crop residue open burning. So here I started for crop because it's just abbreviation, and then emission. So the CROB is widely practiced in Asia and is projected to increase in the short and medium terms. And if there are no strong measures to be implemented, so that we are projected to increase because people produce more to meet the domestic demand and also export. So these activities emit huge amount of pollutants, including toxic pollutants like gases, like carbon monoxide I mentioned earlier, VOC, particulate matter, and also carcinogenic compounds like PHs. When PHs stay for the polycyclic or aromatic hydrocarbons, so that is very prevalent carcinogen in the air, and it comes from incomplete combustion process, and including also dioxin. It emits huge amount of short-lived climate pollutants, so black carbon, brown carbon, VOC, and then a lot of them are being ozone precursors, so it means that in the atmosphere, it participates in photochemical smoke reaction and forming ozone. And ozone, as you know, is a greenhouse gas, and it's toxic to human health, and it's phytotoxic. It means toxic to plants. So worse is that this open burning activity normally happen in dry season when it harvesting happen. And in dry season, the air already stagnant without wet removal, so it intensifies or exacerbates the level of the pollution in the air. So this is a few pictures of rice straw open burning in the field, so like in Thailand. In Vietnam, they also burn it in the village after they take the seed, so then the rice straw left also burn, and then sugarcane burning. Okay, she showed a Haze episode in Bangkok in January. So this is when we have stagnant air and we have huge emission, we have less removal, and then we also have rice straw burning activity. So that it causes very high level of PM 2.5, for example, 24-hour level is up to 80 something to 90, 100 in few days, and it shows the regional effects because up and different stations showing similar trends of the regional effect, and the air quality is really unhealthy. And back then people wear masks because of PM 2.5, because that time there was no COVID yet. So in Delhi, in India, I know nowadays it's burning, but this is actually a huge episode in October 2016. So the burning of crop residue in Punjab and Haryana transport to central and southern state of India and affect air quality around Delhi in the period from mid-October to mid-November, and we have huge episode in 2016. So for the emission from rice straw in burning, so we first try to, at AIT, we conduct some emission monitoring. So we try to do the monitoring in the field when it have open burning, so and to try to quantify the emission factor using some, say, mass material balance method or carbon balance. And we also bring the rice straw into the lab and try to burn it and try to quantify the emission factor, and also measure element carbon, organic carbon, and PM at different sites, and try to see where we see most, which size range. Sorry. So we see most of PM emission PM 2.5. Actually, this is the size range, and here PM 2.5. Most of PM and organic carbon and element carbon actually into the fine particle fraction. And then for the lab experiment, we also do the measurement with different moisture content or different water we collected in the petty area. So this is water come from both the rice straw we collected and the petty soil we collected. So you can see here clearly that when we have high moisture content, okay, of water here, okay, high moisture content of the rice straw and paddy soil, we have high emission factor, the high emission of PM per square meter of the paddy burn. So for the emission inventory, we try to do the emission inventory in Southeast Asia. And here, the first show you the annual amount of CROB residue subjected to urban burning in teragram per year. And here we see also annually, Southeast Asian actually we burn around 170 to 180 teragram of the biomass. So as you can see, this is valuable resource, but we get rid of by open burning. And the most of them actually come from rice straw, because we are actually rice growing countries. And the major contributor including Indonesia, Vietnam, Thailand, Myanmar, and Philippines. Other countries have small contribution. So in terms of emission, so we quantify emission here in teragram per year. And here you can see this is logarithmic scale because it's easy to be seen, but I also put the value directly here. So we quantify emission of different gases and PM10, PM2.5, black carbon, organic carbon, greenhouse gases, and PHGs. And we also include air toxic like benzoylpyrene, is the most carcinogenic compounds among the PHGs, and dioxin, and the total organochlorinated pesticide emitted from the petrifin combustion, and total active chlorine. So you see that huge amount of emission come from this CROB residue urban burning activity in Southeast Asia, and then including also very highly toxic pollutant, carcinogenic pollutant. And rice straw urban burning actually have major share, sharing from 70 to more than 95% of the total CROB residue urban burning emission in Southeast Asia. When we compare the CROB with the forest fire emission, so overall for whole Southeast Asian country, the crops contribute from 12 to 45% of total, the sum of forest fire plus CROB residue in burning. So it means that forest fire contribute more. However, in some countries like Vietnam and Philippines, the CROB residue emission actually higher than forest fire. While in Indonesia, Thailand, and Myanmar, the forest fire emission is higher than CROB residue in burning. What is important here is that CROB residue open burning happen daily over extended periods. So the whole month of the harvesting in an area, so daily you can see patches of the open burning. And it happens where people live. That's why we have more health risks from this CROB residue open burning activity. Talking about effect on ambient air quality, I mentioned that we have an AIRPET project, and the AIRPET project actually happened from 2000 to 2010, and we include IIT Madras with Chennai city presented here. So this is AIRPET project result showing the season level of PM2.5 and composition in 6 cities, including Bangkok, Beijing, Chennai, Bandung, Manila, and Hanoi. I was a coordinator of that international project, actually. And then we find very high level in Beijing during both dry and wet season. And this is the PM2.5. And you see different color here is the composition, like black color like this soot, dotted like this is organic matters. We have nitrate, we have sulfate, etc. So this is PM11 and composition data. It's very important for us because we can use it for source apportionment study using receptor model. So receptor model show here for Beijing, for Hanoi, and the green color here is biomass open burning. So you can see here the biomass open burning. So, and mainly in Hanoi, no forest. So it means that we have here actually rice straw in burning. Same in Bangkok. So Bangkok also have no forest. So this is percent contribution in green color here is actually rice straw open burning. We have the result for also Chennai, okay, preliminary, and then we have Beijing, result for Beijing. Result for Hanoi is published already, but for other we already published in the AIRPET book. So for rice straw open burning, then we talk about Bangkok. So Bangkok or Bangkok surrounding area of Bangkok too. So rice straw is a key crops residue that is subjected to open burning and affect ambient air quality. Here we can see the open burning activity. So this is like when after the harvest for like 1 to 7 days, depend on weather. So people will go there and set it on fire, so that we can see that the fire would take place, and then it actually happened. It finished when everything is burned. So we try first very preliminary research by try to count the hotspot, the number of hotspots, and try to plot it again the PM10 and CO in the station in Rangsit here, AIT here, because that is where the open burning takes place, and we find good correlation. But of course, it's not because of rice straw open burning only, but it's because of dry weather and with stagnant air, etc. But you can also see good correlation. And later on, we have emission inventory and try to help to quantify the emission of different species, including PM2.5, organic carbon, black carbon, and other species here. For example, we found that in the BMR, Bangkok Metropolitan Region in 2016, there was 42 gigagram of PM2.5 emitted per year from own activity. And here you can see the share. 20% of that is from biomass open burning. And this biomass actually rice straw fin burning. On-road actuation 59%, and then we also have thermal power plant, we have industry, etc. But here I want to highlight that this is crop residue fin burning activity, contribute 20% of that. So we try to do the receptor models. So receptor modeling, we need actually composition data, and we have a project in cooperation with JICA, Japan, sponsored by JICA. And we do measurement for 1.5 years of PM2.5 in PCD station in downtown of Bangkok and at AIT, where my university plays. And we find during wet season, the mass concentration season average around 15 micrograms per cubic meter. And the source apportionment shows that around 26-28% of that come from biomass open burning. Okay. Traffic is 29.8% here, and we have secondary inorganic air zone, and then we have different other sources. And here traffic 28%, but quite consistent during two sites. One is actually downtown, another one is actually at suburb area. So during dry season, the level is reaching almost 29 to 31 here. And then we find that huge contribution, 41% come from the rice straw open burning at AIT, because again, I mentioned AIT located near in the middle of greenfield. So a lot of rice plantation area around. And in Bangkok, it's 34%. When you convert it, it's actually around 14 micrograms per cubic meter alone come from the rice straw burning. And then people will say, okay, it's only higher than the WHO guidelines, but it's true, but it's for dry season. Okay, so we have also found secondary inorganic pollutant. So it comes from industry, long-range transport, from agricultural activity, etc. So the more important that I want to draw your attention is the effect on level of organic pollutants. So here we set up study one, we measure it very green area of nation park, remote area where no open burning, no rice straw. Prescribed burning there, but it's not much. And then in Krong Luang area near AIT, there's a lot of open burning. And this is pH is 11, and I mentioned it polycyclic aromatic hydrocarbon, concentrated compounds. And these are different compounds. Okay? And you can see that at Khao Sai Park, when we are no open burning, so during the same season, like dry or wet, we have very low level of pHs, very low. Even in wet season, Khao Sai have a little bit higher pHs than dry season. Okay. And the level in Krong Luang clearly very high during the dry season. And then the level we measure in the rice straw open burning smoke plume, actually very high because the scale here I divide by 5. So you have multiplied by 5 here, we have 4,000 something, okay? So for OCP, OCP say for organochlorinated pesticide. So this is the compounds that many of them are carcinogenic. So we also measure it in ambient air of these two areas. So we actually could not find the difference between OCP level during dry or wet season, or during, in Khao Sai Park and in Krong Luang area, the level more or less the same. So it say that, okay, the rice straw open burning not the key contributor for OCP. However, we find quite high level in the smoke. It may be actually re-emitted of pesticide because it already applied previously in the petty film. And then when we have open burning, the heat make it re-emitted. So then in Hanoi, the picture here we show also we did the monitoring for 1 month, supposed to be very intensive rice straw burning months, because this is also a big source of concern in Hanoi. And then we find that, okay, and rainy, when it's rainy, there are no open burning. But after rainy for a couple of days, people start burning. We have high level of PM2.5, and then raining again, and no burning. And then we observe by eye when it's open burning, we see a lot of PM2.5. So that also shows that open burning of rice straw is also one of the key sources in Hanoi area. So this is a study by Chinese college showing the crop residue open burning and air quality in China. So here the hotspot showing the crop residue open burning activity. So, and then here the place where we have high PM 2.5. This is PM10 in 2016, PM2.5 in 2016, PM10 in 2017, and PM2.5 in 2017. And the conclusion from the paper is that very strong correlation in these northeast counties, okay? especially during burning concentrated period. You see very high correlation between hotspot, showing crop residue, open burning, and concentration of PM in the air. So what further we need to do the analysis. So now we try to run CTM. CTM stands for chemical transport model, and try to simulate different scenario. And this is for Bangkok case. First, we try to actually simulate with 0 rice straw open burning and see how much a reduction in PM and ozone air quality in Bangkok. And this is showing the monthly concentration reduction when we do 0 rice straw open burning. So we can reduce actually PM 2.5, PM10, monthly average maximum by 6 microgram per cubic meter. So that monthly average can reduce by 6. If we actually totally ban rice straw open burning in Bangkok metropolitan region. So now with the ozone, so because rice straw open burning emit VOC, NOx, etc., so it forms ozone in the air. We also try to see how much reduction in ozone air quality if we put 0 rice straw open burning. So it turned out that we can reduce in 1 hour ozone, 1 hour average, ozone concentration on average by 4 ppb in the station called Rangsit station. Okay? Rangsit is next to AIT. So it means that if we don't burn rice straw, so we can reduce the PM level, and we can reduce ozone level. So further, we do Southeast Asia modeling for assessment of emission scenario on radiative forcing and human health. So first, we try to develop and refine emission inventory in Southeast Asia for 2007 and try to run the model, evaluate the model, and publish one paper. Okay. The second, we try to project emission under business as usual until 2030, and under the emission reduction scenario until 2030 for the key measure to reduce black carbon emission. Okay, and focusing in two big countries, Indonesia and Thailand, and try to assess impact on human health and and climate. Okay. So the key emission reduction measure we consider is from residential sectors, the transport sector, and industry. With open burning considered like we actually ban the crop residue open burning, while forest fires open burning reduction like by 80%, just following master plan. So this is the results. So first, black carbon. If we reduce black carbon, so we also reduce PM 2.5, you know that. So, and then here we try to quantify the black carbon, say direct radiative forcing effect. It means that effect on climate. So we see the maximum annual value in Southeast Asian domain under the business as usual. You can see here, and that is 2.0 watt per square meter. Under the emission reduction scenario, maximum is here. Okay, and then it's 1.4 watt per square meter. So it means that we can avoid 0.6 watt per square meter in terms of climate forcing. In terms of human health effects, so we can avoid the deaths. So it means the difference between the business as usual and reduction scenario. So mortality per 100,000 population so can be avoided in Indonesia by 49 cases and in Thailand 36 cases. So it shows the benefit for air quality, for climate, and also for human health. Okay. Now, the last part of my talk is about crop residue management for emission reduction. As you can see earlier, that UNEP and WHO have reports called Integrated Assessment of Black Carbon and Tropospheric Ozone. And then they consider many measures, and the red color here is agricultural measures. So agricultural measures for black carbon, meaning ban of the fin burning activity. And you can see that this is reduction, how much we can reduce in terms of the emission of different pollutants, right? So if we actually ban globally the open burning of crop residue. So UNEP last year, I mentioned already about 25 solutions for Asian Pacific. And that also we have Indian scientists participated in this solution report. So one of the measures here shows that agricultural crop residue. So it can, if we implemented the measure, we can avoid up to 1.5 exposure, 1.5, reduce the exposure level of PM 2.5 by 1.5 microgram per cubic meters. Now, some example of rice straw management. So here, how we do rice straw management, we have the combined harvester, and then we have rice straws scattered in the field. So we could collect it and transport it, like using a truck like this. And we use it actually for different, like mushroom growing, etc. So we have many non-open burning alternatives, like using for mushroom growing, gardening, on-site treatment, use as fuel and for fuel production. The challenge here is rice straw collection and transport, very bulky, difficult to transport, even to collect, need to spend a lot of labor for that. And the rice straw also have high silica content, low energy content, so it may be difficult for animal feeding, for example. So low energy content, it means it's not very good for the fuel, etc. The management term, we can ban it, or can we ban it? So we can issue a ban, but the enforcement may be a big problem. Or we allow them to burn, primarily it is dry and good dispersion, and when and how. So it's actually a very, very tricky question to answer. So this is our activity. I want to show it in the video, so I will skip it, right? So in the PEER project, so we help the following up PEER projects. So here we try to produce the rice straw pellets, and we use it for cooking with Mimimoto gasifier cookstove, very clean cookstove. So first, the rice straw collected needs to be ground it to the proper size, mixed with some additive, and we have a pelletizing machine to press it to make pellets, and this is the dry pellets, and we put it in the cookstove, the Mimimoto cookstove, and it can be used like burn almost smokeless, okay? And the ash produced actually very soft that can be used for soil conditioning, for example. So this is one of the output of our PEER project, and then this is the award actually given to be conducted in Hanoi. Okay, so we try to quantify the benefit to air quality and climate if actually the rice straw pellet and the Mimimoto cookstove can be used, and to replace all the use of solid fuel at present, like wood, coal, and charcoal for cooking in different countries. And we consider 3 countries: Thailand, Vietnam, and Cambodia. So Cambodia have very small amount of rice straw open burning now, so the benefit, this is avoided emission, right? Benefit is small. But Vietnam burn a lot of rice straw right now, and then they also use a lot of wood fuel. So if we turn this rice straw into rice straw pellet and avoid it on this wood and coal and charcoal, so we could reduce that much actually emission of own toxic pollutant like PM2.5, okay? And then we have this. And including also greenhouse gases and global warming of short-lived climate pollutant in teragram on a huge amount, meaning that we can achieve the air quality and the climate benefits. So in terms of health benefit, we try to measure the indoor PM2.5 in kitchen. This is actually the experiment conducted in Hanoi. So this is LPG, the PM2.5, right? When we do cooking with LPG, the level measured inside kitchen and in sitting room will seem to be low. Okay? So it's really low, not that much, because some disturbance here. But when we use rice straw pellets for cooking, at ignition, when we start the fire, we use some kerosene, so it's huge emission. But then at level 80, 100 something, and inside kitchen remain a little bit high, and after that it reduces. So now if we use corn briquettes, so in Vietnam they use honeycomb briquettes, so that's very polluted fuel. And when we use that fuel, the level turns very, very high. So it means that in terms of the reduction, so emission reduction in indoor air pollution level, the pellets actually help to reduce if compared to briquettes, but of course it's not as clean as LPG used for cooking. So in terms of policy recommendation, we actually try to recommend, this is output from our project, and we try to produce some policy recommendation, try to raise awareness of adverse health effect of rice straw open burning, try to strengthen enforcement of the existing urban burning related policy, provide a subsidy for development of a pilot scale business model for producing dry straw pellets, and provide a subsidy to farmers for improved gasifier cookstove because they need to buy this cookstove and it costs them actually $60. But the subsidy is $20. And incorporate the alternate dry straw pelletizing in the crop residue management strategy. So this is actually recommendation from our project. So in summary, the urban burning of crop residue is an important emission source in Asian countries because we actually agricultural-based economies. So emissions from crop residue urban burning are higher than forest fire in several Southeast Asian countries. It shows that it's very important. So the intensive emission in dry and harvesting season would contribute to already quite high level of pollution there and forming haze episodes. So the serious effect on ambient air quality. So non-open burning alternative provide multiple benefits to air quality, health, ecosystem, and climate. And that's why we would like to have this policy recommendation. So overall, I would like to say, we should say no to rice straw fin burning, but not only rice straw, but crop residue fin burning activity. And I know in India, you also burn rice straw. You have wheat and straw, and we actually have also the panel discussion later on here. So thank you very much, everyone.
Thank you, Professor Kim Oanh. Very interesting presentation and very nicely well covered, starting from the basic of air pollution till to the stubble burning issues, which many countries are facing because of the, the larger quantity of, straw being burned in the different places. So we will quickly take up some questions which already they have started putting in the chat box. Maybe after that, maybe we'll start the panel discussion. This question is from the Sotoris. He asked, could rice straw provide additional feed for the livestock?
Okay. So the question is if rice straw is additional feed for livestock?
Yes.
Yes, we actually do practice that, but rice straw is very difficult to digest, had very poor digestibility because of high silica content. But in the past, people also use it, and now also people use it when actually a lack of the actually grass or other type of food. So that's why animal would not get big of healthy with that food forever. But during the winter season, so sometimes people also use it supplementary with other things like grain and other type of food mixed with that to make it feel actually full.
Okay. Yeah. Thank you. So I just had questions based on your presentations. I was really, exact. Is there any way to quantify you also carried out a source apportionment, mentioned some aspect of that. So is it a significant source? For example, if try to look at it, the major agricultural area and how it is being transported to the downwind. Suppose if the wind carries all these pollutants from the agricultural burning area, then do you expect that the near the city will have a major contribution as the distance varies, the contribution significantly decreases. So have you noticed some relations in this direction?
The distance here, like you see my slide now, right? Mm-hmm. The PCD actually stay in the middle of Bangkok, okay? Mm. And AIT is in a suburb area. Okay. Wish that you could actually visit us next year to see it. So we are surrounded by by agricultural fin. Okay, so with this you can see like the biomass burning in AIT is mainly the rice straw. While in PCD we think of post rice straw and maybe charcoal, they use for street cooking maybe contributed because we could not separate these two. But in terms of the distance, I think Bangkok and other Asian cities, we have very mixed land use pattern. So we have urban surrounded by agricultural land, and then we have rural, so that everything mixed. So that's why we don't see good separation of the agricultural field and then the living place, like not like in Europe, for example. So that's why the Bangkok is surrounded by 6 other provinces, and all of them are planted rice. So that's why wind direction from any direction also you can see the impact of the transport to Bangkok. But one AIT actually located middle of the rice plantation area. So you can see very high contribution during dry season, and then if we calculate it, I say if we calculate it, it's 14 microgram per cubic meter come from rice straw fin burning activity. So people are also looking, okay, it's higher than WHO guideline. But this is only during the dry season, right? In wet season level, contribution a little bit less. But however, the crop residue urban burning, the source, because it's not permanently, so it's like it covered up months. Everybody actually gets shocked with that, and everyone says, okay, we should stop it. But in a few weeks, when we plant new rice, and you see the green rice around the field, the people forget about that. So that is problem. So that's it, not like traffic. So it's every day. But this is like seasonality, very high seasonality. So, okay. And that's why if the policy, we need to recommend very consistent policy and a very good way of implementation in order to enforce it through. Otherwise, people forget about that. And then remember again when we have that event.
Okay. Yeah, thank you very much. So I have another question this is from Dr. Madhusudan. Any correlation study on meteorological parameters with increase in PM 2.5 or PM 10 with reference to the stubble burning emissions?
I believe it would be in the chart screen or not?
It is in the chart screen. So shall I repeat the question?
Yeah, you better repeat it slowly.
Okay, I'll read it very slowly. Okay, any correlation study on meteorological parameters with increase in PM 2.5 or PM 10 concentrations emitted from the stubble burning?
Okay, good question. Thank you. So we didn't do that correlation study, but I have a study on health exposure to PM10 in Chiang Mai. And we actually classify, you see the synoptic map here, we classify this synoptic map into 5 patterns. Mm-hmm. And then a few patterns have very high level of PM. And that pattern normally have stagnant meteorological condition with dry air. And that's why with stagnant, it means we talk about high pressure system here. So we actually do not do it one by one, but we consider meteorology at a totality. A totality is shown at synoptic pattern or weather pattern. And then during certain weather pattern, we can have very high level of PM. And that also dry pattern, it means less rain. So that when we also see the hotspot, the high number of hotspots. So I have a study of that, and I actually don't put it here. But if you're a PhD student, right, or your colleagues?
No, he's a colleague. Actually, he's actually retired from the policy department.
Okay. Anyway, I can send him the paper.
Okay.
Because it's quite long.
Okay. Yeah. Thanks, Professor Kim. And now 2 more questions are there. So one is from Dr. Hanju. Despite of government measures in North India, still stubble burning exists, one of the main issue. Can you suggest from your experience, how can we tackle the burning issue? So you all you know that you showed that there is a stubble burning issue just about a few days back. So how can we manage this based on your experience? How can we tackle this particular problem?
Okay, I think we put it into the second part, right?
Hmm.
For the panel discussion, because it's long question and long answer. Is it? Can we put it in the second part?
Yes, yes. Okay. Maybe we will take up during the panel discussion. Okay,
Yeah.
very nice.
For panel discussion, because it would be very, very long answer.
Yeah, this Dr. Vera has come out as one question. It's a follow-up question. Would those currently burning this stubble be happy to change their behavior? So what have you noticed some changes in behavior when you suggest that don't do this stubble burning?
Very difficult to change their mindset because I know first I start with this and then I say, okay, wow, it may be easier than transport. But then it turned out not easier than transport because here we deal with farmers, right? And farmer, it's very difficult to regulate the farmers. If you ban them during daytime, they burn during nighttime, right? And then you may ask them, why you burn it? They say, no, I didn't burn it. Someone burned it for me or for some reason. So that's why educative measures is very, very important. We need to do some health effect study and try to show that. It's very relevant to CEPHA too. We should show farmers, if they burn, how much their children would exposed to that pollution and how many cases of hospital admission would be there. Okay? And then secondly, if we talk about the urban burning, so the health effects, and then if we can provide some incentives, so some business model, like in our case, we propose some business model to produce the rice straw pellets, okay? And then farmer can bring rice straw and exchange for pellets and get subsidized cookstove, or they can get the money as long as they can make some money from that, or maybe mushroom growing, whatever. But if you simply ban them and give them no other alternatives that beneficial for them, it's very difficult. So it's not low-hanging fruit that I thought at the beginning. When I did it during the AIRPET, like 20 years ago, I thought, oh, it's low-hanging fruit. Let's do it. But then after 20 years, I recognize it's not low-hanging fruit. It's very tricky. So that's why we are here today, and then panel discussion will talk about that, I guess.
There's another interesting question again from the administrator, Madam Jani Prasad. Does being close to the sea, suppose if an area is close to the sea, have an effect on PM pollution even if stubble burning happens? So for just like a Chennai city, if there is a significant contribution from the stubble burning, can the sea breeze and land breeze will have an effect?
I did not get the question. Can you repeat it?
I'll repeat the question. Does being close to the sea have an effect on PM pollution even if stubble burning happens?
Sea actually give you, if you have sea breeze, right? The
Yes.
good wind, good dispersion.
Yes.
It help a lot to reduce pollution level. And I guess Chennai also have a lot of traffic. Sea only give you a very, very small amount of sea zone in PM 2.5, that is. But Chennai have traffic, Chennai have industry, so that contribute a lot. And then stubble burning also contribute to that. But talking about close to the seas, we talk about the sea breeze, or we talk about good dispersion like Bangkok, right? Bangkok normally say, okay, we have this good dispersion. But in the past, we enjoy it. But when the pollution emission actually get to some certain level, so the haze episode happened. So that's why in the past I mentioned we have the same synaptic pattern, but then we did not have the haze that much. But right now we have haze very often, and the meteorological pattern also similar. This is because we have too high pollution level. Okay, so this again the interlink between meteorological condition and emission. Okay, the meteorology is there, and long ago it was there, the same condition, but we did not have haze, and now we have a lot of haze.
Okay. Thank you. Yeah, thank you very much, Professor Kim Oanh. So I think we will start the panel discussion. On behalf of IIT Madras and GCRF-Clean Environment and Planetary Health in Asia, CEPHA, our CEPHA network, and Indian International Conference on Air Quality Management, we thank you very much for your time and taking out of your busy schedule to give this very important talk, particularly to addressing this stubble burning, which is another major issue in the country. So now we will move to the panel discussion, and of course we were not in a position to give any memento to you, but we will find some opportunity when you are visiting IIT Madras. We will definitely make an occasion to share this joyous moment.
Okay, thank you. Thank you
very
much. Thank you. I also enjoyed it, the meeting. Thank you.
Thank you very much. So I'll just about take about 2-3 minutes break, and then I'll request Dr. Madhusudan to introduce the panelist for the to the audience, and then we will start the panel discussion. So now I'll move this over to Dr. Madhusudan. So I would like to thank all the participants who are attending this, who attended this particular lecture, and we will welcome you to join for our panel discussion.
So, good afternoon, everybody, and good evening and good morning to other people present elsewhere. See, today's panel discussion, we are talking about the continuation of what Professor Kim Oanh has discussed. So we have 6 panelists here. Out of that, Prarthana Bora, she is the Indian Director of Clean Air Asia International. Since she is not well, she may not be participating in the panel discussion. However, on behalf of the CEPHA network, we welcome her. Otherwise, we have 3 panelists from abroad and 2 from India. And it is my immense pleasure to introduce the panelists. And Dr. Sotis is the inaugural professor of global environmental health at Australia National University. And he have experience more than 20 years. Sotis has advised the national and local governments and international organizations such as World Health Organization, European Parliament, and UK government. He is the founder and co-chair of International Consortium of Urban Environmental Health and Sustainability. Professor, we welcome you to this today's panel discussions. And yeah.
Thank you, Doctor. Thank you, everybody. I really enjoyed the presentation, Kim Ohan's presentation. Congratulations, Kim Oanh. Fantastic tour de force about this so important issue related to air quality and health. And I would like to congratulate Professor Shiva and all the team at Chennai for the excellent series of lectures and the conference they're organizing. Thank you very much, and I look forward to the discussion today.
Yeah, welcome you, sir. The next panelist is Dr. Prashant Kumar. He is the professor and chair in Air Quality and Health, founder director of Global Center for Clean Air Research and he is from University of Surrey, UK. His multidisciplinary research builds an understanding of the formation, emission, and exposure of particles, both from vehicle exhaust and non-vehicular sources. Right now, I think he is not to be seen. I think he will be joining with our panel discussion soon. However, we welcome you, sir, for this discussion today. And then we have Dr. V.K. Shukla. He is my colleague, and the additional director is Central Pollution Control Board. He is working in the field of environmental management for the last 25 years. He have vast experience as the management aspects of Taj trapezium zone, as well as he played a major important role in the management of air quality in Delhi and NCR. At present, he is working as the head of the air quality monitoring network of India, and he has the additional responsibility to see that how the air quality of Delhi and NCR is under control. And then welcome V.K. Shuklaji.
Thank you, Dr. Madhusudan, and thank you, Professor Juan Nagendra, IIT Madras, and CPHA Network for inviting me. My apologies, I missed the lecture because of some issues here at our end, but I'll follow the discussion. Thank you so much.
Thank you, thank you. I think I need not introduce now the Professor Kim Oanh. We enjoyed the last 1 hour with her experience and expertise in describing the stubble burning and the issues the South Asia as a whole. So, Madam, we again welcome you to the panel discussions.
Thank you.
Yeah. And now I have to formally welcome Dr. Shivanagendra, our backbone in the department. And I need not read out his qualifications or his achievements. And what we are here today, why we are discussing all these issues, it is one of his efforts that coordinating the universities, the researchers, and the regulators, and how we can coordinate and control the air pollution, not only in the country as a Asia Pacific region. We have a wider CEPHA network where he is the chairman of that one, and also he is the vice president of Society of Indoor Environment. And we welcome you, sir, to this panel discussion. Formally, we welcome you, sir.
Yeah, thank you very much, Dr. Madhusudan, for giving me an excellent introduction to all the panelists. So we will take up, maybe we will see, since it is online panel discussion, probably maybe we'll start with 2 minutes each. The panelists can brief about their ideas and experience with stubble burning, and probably meantime the participants or attendees can just put their questions, and then we will Anju, you have the question poll available to you, and you can share that with in the question in the chat box, and the panelists can also make use of that and during the discussion.
Yes,
okay,
sir.
so now I'll request Professor Soteris, and you all know that of course air quality management is a major issue, and most of us will spend although enough activities, enough resources being spent on water management, but just like similar to water, and air is also important, and particularly this kind of a pandemic, we really more care for better air. So, looking at this aspect, and we are happy to see that many expertise who are part of our ongoing project CEPHA network. So we just to see that how our participation will be benefit each other, because there are some good learning examples, like just like what we learned from Professor Kim Oanh. So similarly, Professor Satori is having an interesting experience from the bushfires in the Australia. So like several people have been working in a different aspect, and probably we will try to bring out during the discussions. So now I'll hand over to Professor Satoris, and then set up the scene for rest of our panel discussion. And thank you, Madhusudan, and please you can also join whenever you feel.
Thank you.
So over to Professor Satoris.
Thank you, Professor Siva. Thank you for this introduction. So I will say a few words about air pollution and health, and try to set the scene for the discussion. So we know that air pollution is a big problem for public health. We know that it's responsible for around 7 million deaths, attributable deaths every year across the world. Many of these deaths are in India, and China, and Southeast Asia. And what is important, what is the important thing to highlight is that air pollution doesn't recognize borders. And we experienced that with the bushfires in Australia. So we know that the smoke from the bushfires, we had catastrophic bushfires last year, the smoke traveled over hundreds of kilometers. It was detected in New Zealand, it was detected even in Latin America on the other side of the Pacific. And we estimated that around 10 million people were affected in Australia by the smoke from the bushfires. We had around 400 attributable deaths, which is much more than the deaths which were caused directly by the fires. So the people who died, we had around 40 people tragically dying on the fire front, but many more deaths attributable to the smoke from those events. And similar kind of situation is experienced yearly in Southeast Asia because of the agricultural burning. We have the seasonal period of burning every year, and that affects neighboring countries. So sometimes the burning is in northern Thailand. We have a very productive project with Professor Kreichat of Mahidol University, who's now on the line today. And in this project, we have quantified the impacts of PM2.5 of the smoke from agricultural burning and wildfires on human health in Thailand. And and some of this smoke comes from the northern parts of Thailand, but comes also from other countries, neighboring countries, and also it affects the whole region. So it's a regional problem, as Professor Kim Oanh was explaining with the modeling studies. It affects also big cities like Bangkok, big cities which are not very close to the main areas where the agricultural burning takes place. And it also affects indoor air quality. So the smoke, it's impossible to keep the smoke, to keep it outside the house. So the smoke eventually will infiltrate into the household environment, and it can expose people at risk, vulnerable populations, young children, the elderly, pregnant women, people with existing illness can be exposed to smoke from these sources for long periods of time. And that can have implications for their health. So it's a very complicated problem. Of course, agricultural burning has happened traditionally. There's a culture of doing that. There's a practice for many years in many parts of the world. It's actually a resurgent practice in Australia. So even in Australia, it happens to some extent. And it's very difficult to change this practice because obviously it's cheaper for farmers to burn the crop residuals, and the alternative solutions are perceived as more expensive and more difficult to implement. However, as Professor Kim Oanh presented, there are alternatives, and some of these alternatives are very attractive if one takes into account the full cost of the health impacts, the health services use, and also the alternative, the benefits of using the rice straw or other residues in in other industries, in the production of pellets or for livestock feeding. So there are other uses of these residues which can reduce the environmental impact, can reduce the impact on air quality, also the impact on water quality, and the ecological impacts from the fires. Also by maintaining in some cases, certain amount of these agricultural residues that helps maintain the moisture in the soil and the nutrients. So there are certain benefits of retaining some of these crop residues in the soil, and this is what we have experienced also in Australia. So as I said, a very complex problem, but also potentially a number of solutions which can help reduce air pollution, improve air quality, and provide other co-benefits in other industries. I will pause here. Thanks for the opportunity to discuss, and I look forward to the discussion, to the views of other panelists.
Thanks, Professor Tris. Now, maybe we'll move on to Professor Shukla. Dr. Shukla, would you like to share your thoughts from the regulator side?
Yes, Professor Nagendra, thank you first of all. I'll give the perspective of stubble burning which is happening in northern part of the country, especially I think everybody is aware, or most of the people must be aware that Punjab and Haryana, they are the western, in the western part of this country, in the northern plains. They contribute very significantly towards stubble burning. And during this season, that means in winter season, Delhi and surrounding areas, especially Indo-Gangetic Plain, that experience a very high level of air pollution. And in the winter, especially because mixing height comes down and meteorological conditions with lower temperature are so that dispersion doesn't happen. And in the beginning, that means around October, this stubble burning starts because this is basically paddy crop, which is harvested in October. And it is a very fertile land, Punjab and Haryana, and farmers try to remove the stubble in a very short span of time. That means they get hardly 15 to 20 days to prepare the fields for next crop, that is wheat crop. So a lot of stubble is generated. If I could give you a number, it is around 20 million ton in Punjab and roughly around, you can say 7 million ton in Haryana. So in Punjab, 50% is around stubble is burnt. That means around roughly 10 million ton. And little less in Haryana. So this is the kind of scenario. And what happens during winter season, the wind direction is such that anything burnt in western side of the Delhi, even certain reports indicate that even from Pakistan also, because agricultural practices are nearly same in both the sides. So wind direction is such that these pollutants, which are primary pollutants as well as secondary pollutants also, they travel towards Delhi. And this coincides with the meteorological conditions, lower temperature, as I mentioned, mixing height, and certain festivals during this period of time. So this travels and aggravates the situation. Not only this stubble burning, but internal sources of pollution are already there in this region. In terms of dust, a lot of vehicle, and this is highly populated region of the country. So a lot of energy consumption, and agriculturally it is a very rich region. So, so a lot of internal pollutants emissions through anthropogenic activities, coupled by meteorological conditions, and this additional source of stubble, which is around, you can say, roughly a month or so, 15th October to 15th November. So this creates such a situation, especially in Delhi, that you get severe air quality conditions. In fact, in first week of November, we had certain episodes of this stubble burning, and the contribution of stubble was estimated at peak level around 42% in air pollution. So it ranges day to day because the type of uh, activities they are doing there in Punjab and travel time, etc., and meteorology, wind speed, etc. But on certain days, it ranged between 30 to 40%. On an average, it is if for the period it is around 10 to 12%. So this additionality in air pollutants create a very big problem in this region. And these pollutants stay in this region. That's been Delhi around Indo-Gangetic Plain. And so background levels increases. So this is a big problem. Now, as for, so to address this issue, and it comes every year. So this is a big problem. Now, what initiative, a lot of initiatives have been taken by the government. So the major focus was to manage the stubble through in situ management. That means to manage the stubble within the field itself. And since farmers are of, they are rich farmers also, big farmers, as well as with the small holdings also. So government provided a lot of subsidies to farmers and provided a lot of machinery which could be utilized to manage this stubble through in situ mechanism. So, to provide this facility to poor farmers, that means marginal farmers, common custom hiring centers were established in Punjab and Haryana. So, thousands of centers, in fact, last year, more than 10,000 centers were established so that farmers could hire those machinery and use them. So, it was partially, it was successful, but this year somehow number has gone up of active fire events, which we monitor through remote sensing agencies with the state pollution control boards and other agencies and Ministry of Environment, Forest and Ministry of Agriculture, etc. They also keep track of the situation. So somehow because of COVID situation, implementation may be little poor, or there was some agitation also because of some farmers' milled, etc. So there are certain factors. So active fire events count has gone up, and that resulted into poor air quality, contribution of pollutants for air quality. One more issue was that some farmers were reluctant to adopt the in situ practices. So government thought of promoting ex situ management practices also, wherein subsidy was given to farmers for balers, etc., so that stubble can be removed and it could be utilized for other processes. For example, for biomass power plants, ethanol plants, and bio-CNG plants. So these practices are now being adopted. And it is assumed that in Haryana, at least they'll be able to utilize all the balance stubble in due course of time next year. So subsidy, and one more thing which was important, that a lot of awareness programs were undertaken. So farmers are aware that it is harmful, but probably they need more support in terms of finances or such policies which could utilize the stubble in that area, and some technologies, if they could be put into the use there, so they could utilize, and more entrepreneur probably may come and attempt utilizing. And you might have heard, many people might have heard that decomposer solution, RAI has come out with one technology. So that is also being tried. So we are hoping that in times to come, things will improve and will have less impact of stubble. I'll be happy to intervene if questions are there, or if you.
Thank you very much. I think I also welcome Prashant has just joined now. I welcome him now. Before moving to him, because they'll give some time for him to settle, then I just request Professor Kim Hon to give. There are two issues which is which you already also highlighted in your during your talk. One is the quantity which is that need to be addressed. Stubble is a large quantity that need to be managed in a very short time period. And the meteorology is another thing which is happening because of the season. So what is your your experience with that, and maybe you can you just highlight and again set a scene for the panel discussion?
Yes, thank you. Yes, the huge quantity of crop residue is being get rid of by open burning. And if we actually can turn that quantity and recognize it as valuable resource rather than waste. So resource, it means that we can recover it. Like in my project, we try to put it in the fuel. So the crop residue burning actually very challenging, as you already know, because it happened during like dry season when the level already high. So it happened actually very concentrated in the rural area, and it have high exposure. But at the same time, during 1 month, it was very high. But next month it is low. So then authority and people just forget about that. So somehow we need to actually continue our efforts, at least to educate, like educative measures to raise awareness of farmers and of policymakers too. So every stakeholder, so it's not only farmer, because people get exposed to that. So if we can like have all the stakeholders join hands to solve the problem, so we have a chance to success. Otherwise, if we leave it to farmer, the farmer of course would like to burn, because it's very easy to get it burned with minimum labor cost. But then effect on air quality, they say, like when we interview Thai farmers, they say, okay, it happened only half an hour, then it's gone. So, and not noticing that it actually affect on air quality, because every family burn for half an hour, and then it actually happen everywhere in the village. So it was very high level. And it's not only in the village, but it also transported downwind. So I would think of about awareness raising, like CEPHA. People can also do some exposure monitoring during that period, and try to quantify the exposure and link to some health effect using certain type of sensor, like Radiative sensor or other, like measuring oxygen content, measuring blood pressure, in order to show it to farmer, and some survey during the period to show high rates of the, say, hospital admission or the kind of disease like coughing, etc. So like give farmers some good, like type of good information for them to go to change their mindset. But at the same time, I mentioned, for farmers, it's very difficult to regulate them because they are poor. So they have not hard to actually, and the law is so difficult to enforce on them. But if we give them some incentives, like in Vietnam, in Red River, Mekong Delta, so, and also in Red River Delta and Mekong Delta, so it's two rice growing region. So there are certain activity like farm, a business model developed in order to plant the mushroom. So plant the mushroom and have some export. So it means that all the rice straw have been collected very quickly, because people can export it to get money. So that's why we think of some way to help farmers to get some incentive, like also producing fuel. And in Thailand, they try to introduce a very powerful plowing machine in order to plowing the paddy, and try to have an on-site, because we have the flat rice, right? On-site decomposition of rice straw with some enzyme. So, but then the farmer did not like it, because they spend more efforts to do that. We need a powerful machine to do that, and we spend more labor, and we need to wait for a month in order for the rice paddy to get ready for the next crop. And open burning, it costs you only half an hour, and half an hour it go. So that's why really it's not low-hanging fruit to me, and we need everybody to work, all the stakeholders to get involved and be responsible for this. And I know India have a similar situation when we have crop residue open burning a lot. So in Vietnam, in Thailand they ban, but it's not banned because of air pollution. It's banned because of visibility. So it banned along the big road because it causes visibility reduction and it affects transport system. In Vietnam, we did not think of banning it yet because I'm not sure if they are going to ban it, but not right now because we know it's very difficult to enforce farmer. So it's quite challenging. So it's not like an yes, no answer, or there are some definitely correct answer here. So I think we need this is chance for us to explore some idea together and try to do something. At least for CEPHA, I think we can quantify health effects at least, yes, and distribute it to farmers and tell them actually it really affects their children, affect their own health.
Okay.
So that is, thank you.
Yeah. Thank you very much. Now I'll request, I'll invite Professor Prashant to say a few words about this stubble burning issues. In fact, Prashant also involved some of the work in quantifying the sources that contributes air pollution in Delhi. So now I'll request Prashant to say a few words and set the scene for the panel discussion.
Yeah, thank you very much, Professor Siva Nagendra. So I have some first-hand experience as well of this issue because I belong to the North India, and I lived actually quite a lot of my life actually there, and come from a kind of a the farming background. And in fact, I have been doing this in my early days, burning things when we feel that these things are not really necessary. So one of the issues actually we don't, or we never kind of highlight in these circumstances is that why do people burn and what kind of impact actually they are having. So in fact, these are the people who are getting the first-hand exposure before it goes actually to the other places where it's kind of causing problems, like the issue in Delhi, which is kind of a landlocked, and a lot of these these rural areas where these kind of things, the agriculture is happening, people are burning. So the fact is that it has got quite a lot of the impact on the people who are doing this thing. And the reason they do is that there is no other alternative. So basically what they do is, these practices are very different actually in different part of the country. So for example, if you look into the north side of some part of the north.
Can you all
maybe people could mute actually.
Could you please all mute? Only Prashant mic can be on.
So basically, when what they do is like loads of this stuff is recycled by the farmers itself, or by the community, the rural community. So for example, if you talk about the wheat actually, so for different the crops, so there are different kind of practices which are being followed. So for wheats, almost 100% is recycled. So what is done is you take the wheat, but then this all those things is turned into the kind of fodder where it's being fed actually to the animals all across the year. Now the major issue comes with the some of the crops actually that relates the rice. In the rice crop, still a majority of part actually they are recycling it for using it for the food, for the feeder to the animals. But the one actually which is quite highly problematic is the sugarcane. Because what happens is, like if you look at the sugarcane cycle, so the green part actually, so that's been cut off and become the food for the animals. So the farmers usually they take it. the main stem, which is sugarcane, that goes to the to the mills where they can make money out of it. So the part actually which remains is the bit actually which is covering it, the dry part, and there is a very little value of the dry part actually to the farmers, and usually that happens during the winters. So what happens is then they are using that either for for the warming up. So you will see actually a lot of people sitting in the morning and kind of using it and making fire, and then kind of making yourself the heated. So this is one thing. And when the quantity is big, especially with the farmers actually who got the bigger areas, then what they're doing is they are trying to burn it actually in the field itself, and that becomes a kind of a problem. So the one positive thing out of it is that in India, lots of things, almost everything is recycled, and it means that everything has got a value. So one of the bits actually which are completely missing is that the value for this kind of this waste actually has not been kind of put into practice so far. Even the people come and buy the plastic, and the plastic is recycled. So if there are any ways of, let's say, there are some centers or there are technologies which are allowing actually the farmers to sell it, to those places, then I'm sure that there will be not even a single straw actually left in those places, because they all wanted to make money, if there is a value in it. And I understand that there is some technology which has been tried recently, which was kind of degrading, this material into the fields itself, so it can work as a fertilizer, and which is again a very positive thing, because the farmers actually, one of the bigger things out of this thing is not only the emissions, but also the issue of the fertilizer. So there is very little organic fertilizer which goes into the fields. It's mainly relying on the chemicals actually, which is kind of penetrating into the food chain and kind of affecting the people's health all over the world or all over the country, whoever is kind of consuming it. So if you look at the quantities of the fertilizers being used actually for the farming is way higher. And that means that that fertilizer is going into the food chain, but also when this thing is burned actually, so it's kind of reflected in terms of these emissions, which is kind of, inhaled by the people who are kind of, exposed to these kind of emissions. So in my opinion, the one thing which is very important is, this is the grassroots problem, is how do you bring actually value out of this waste? If you can bring value out of this waste, there will be no waste. Because the system is such that everything is recycled, which is a great thing actually. So that's what, if you see the per capita, the carbon footprint of the people in India are way lower than you can expect in the US or in UK or in developed part of the world. So I think this is in my opinion is the key challenge actually, and where I presume that we should really try to emphasize and see what we could do in terms of solving the problem from the root, rather than trying actually to look at its kind of the leaves and the top.
Yeah. Thank you, Prashant.
So I'll stop here.
Thank you, Prashant. I think we have really learned a lot from understanding the issues, but we will try to spend more rest of our discussion towards the mitigation options, because there are key challenges that are existing with stubble burning. We know the key issues. Then we'll try to see that, okay, what are the mitigation options? Maybe probably we will try to move in that direction. Anju, would you like to pose a question and get some feed from all the participants, and then we will continue the discussion. Probably I will invite to pick up the mitigation options, which already Professor Kim Oanh has having an experience, and she's taught the various mitigations and why it is not successful. If we wanted to make it more successful, then what we can learn from her experience. Then probably then we'll move to Satoris. So this is the next set of discussion. So Anju, could you share the questions to participants to give their feedback?
Yes, I'm sharing now. I'm launching the poll. So
Professor
yeah,
I have one this thing. Our former chairman PC Tyagiji is also there in the panel.
Oh, definitely.
Yeah.
Very nice.
Yeah, and also Dr. Deepankar Shah is also, I could see him. So we should
we will invite them.
We will welcome also them as such.
Yeah. Okay, please.
Yeah.
Dr. PC Tyagiji, we welcome you for this workshop and air quality management lecture series, and we would like to see you to give one of the lecture in the future air quality management lecture series. So we welcome you, sir. We also welcome Dr. Shukla and Dr. Shri S.K. Gupta ji. So both of them are eminent, very experienced persons in this particular area. We welcome you. So there is a question we asked whether India should blindly follow technological interventions to control stubble burning. So there are answers. So we say for 14% disagree with 14% are agreeing to that, and 17% are disagree. 71% disagree, and another 14% they are impartial. So maybe I'll just share this information to Professor Kim Oanh, and maybe you can lead us the discussion. Professor Kim Oanh, you are there?
Yeah, I should move myself. Okay. So yeah. So again, very tricky. So I think we should listen to Professor Tyagi. So you have a big person there, and he's on policy, and he's a good scientist. So let's listen to him first, because I mentioned about that a few times in my presentation already, right?
Yeah. Okay. So let's then Anju, could you please keep him, invite him. First, we will see whether Professor Dr. Tyagi sir is can be able to speak and unmute his mic.
Good afternoon to everybody.
Good afternoon, sir.
Thank you much for the honor given to me. But I would like to say that there is always a cycle. In the beginning, a person tries to learn, and also at the end, again, he tries to learn. So the third phase in which I am trying to learn, and that is why I was here. In any case, since you have given me an opportunity to say, my feeling is that this recent development of ICAR to convert the stubble into fertilizer with the help of bio destroyers is a very encouraging development, and I think it will be applicable not only to the rice stubbles, but also to the sugar dried upper parts that are left behind in the field. The question is, this point has to be studied not only as a single process of conversion, but also other effects that it can produce on soil bacteria, because there are very fertile fertilizing bacteria in soil, and whether this particular thing is going to encourage them, compete with them, destroy them, or encourage them, one has to learn all that, because very many times things which came up as very good solutions turned out to very big problems. Plastics is a classical example of it. Now, with these few words and the limited time available in these occasions, thank you very much once again.
Yeah, thank you for your input, sir. Professor Kim Oanh, over to you. And Dr. Tyagi has already given some inputs, and he already said it is a cycle. So we have to learn as the economics and system changes. We should learn from that, and provide some useful solution to the society. So over to you, Kim.
Yes, from a researcher point of view, I am thinking of actually try to provide good science-based information to policymakers. So, of course, besides rice, we have wheat straw. At wheat straw, we don't burn, but sugarcane burning is also, I agree that it's huge amount in Southeast Asia too. And we burn sugarcane because it to ease the harvesting process. And in Thailand, for example, now they use some economical tools. If the sugar factory actually use the burnt sugarcane, so they get some fine in terms of the price. So that's why they need to use the unburned sugarcane in order to guarantee the price they send the sugar. So kind of penalty. And then technology, they also try to alter the way of doing farming in order to use some kind of harvesting machine, so that avoiding that like the touching that sugar, and sugarcane is very sharp, the leaf very difficult. So that's why we try to change the way of planting sugarcane to make it into row, so that a machine can go through that and then cut sugarcane. So this is actually technology, policy, and information. So it need to work together. And again, we all need to work together in order to achieve something. And perhaps some case study can start with like sugarcane or with rice plantation. And India, we have the happy seeder, so that works also very well with wheat straw, I guess. So, but then in our part of the world, we have rice. It means that there are no wheat in between. So then it's only three crops per year that we burn a lot. So it means we are learning from each other, and then we also look forward to learn from the experience in India, for example, in managed crop rescue.
Thank you, Professor Kim. You know that even our participants, they are all disagreeing that we should not blindly follow the technological interventions to control the stubble burning. So I mean, this is something which quite interesting. And now we'll move on to Professor Satoris. Would you like to comment on this?
Thank you. I think if the question were posed without blindly, then the result of the poll might have been different. So if we said that, should we follow the technological interventions without blindly, then we might have got a different result. Anyway, it's an interesting question. It's an interesting question. I would like to say maybe a few words about the economic evaluation of the interventions and whether this could be, whether this could incentivize alternative management of crop residues. I think the issue is what Prashant highlighted, that the household economics and the farming community economics are different from the broader macroeconomics of the whole system, because if we estimate the cost and the benefits, and we estimate the cost to health services or the cost to the economy, if we take into account health services and mortality and morbidity, then we might have a picture that shows that alternative ways of managing crop residues are beneficial. But at the micro scale, when we look at a farming community, an agricultural community, or household, then the horizon is much shorter, and they want to, they want to maintain their income, of course, and maximize their income in the short term. And this is what is very important, to change this relationship between cost and benefits at the micro scale. And to achieve this, the alternatives have to be attractive at individual level, at unit level, And also then we need to raise awareness of the disbenefits, of the health costs, of the health impacts, again at individual level for the people who are directly exposed to these emissions. So I think there is work to be done with macro and micro and macroeconomics and build the economic case, and also raise awareness of the direct health effects of the people exposed to the smoke from those fires in the communities which are directly affected by the practice.
Professor Sotiris, could you also just highlight what's your experience you learned from bushfire? It's also, although it is in a different context, but something we can learn from the Australian bushfire, how it is being managed, and could it be helpful for Indian context?
Thank you. So, the discussion today reminds me a lot of the discussions we have in Australia about prescribed burns. So the way here, the most common way of reducing fire risk is to do some risk reduction burning during winter time. So the idea is to go into the bush, into the forest in winter time, put some fire, and try to reduce the fuel in the forest. So burn the undergrowth. And of course, this is scheduled during winter time when the risk of fires is much lower, and also in periods of time when the dispersion conditions are not favorable for the expansion of these fires. However, these prescribed burns affect local communities. So there is a lot of smoke generated. It affects communities. And there is a lot of argument against this practice. But at the same time, when we have catastrophic bushfires in the summer, people also argue that we should have more prescribed burns in winter time to reduce the risk. So there is this kind of competing needs and priorities which is to reduce the risk of catastrophic bushfires in the summer, but also protect air quality in winter time. And this is quite similar to the issue of the agricultural burning in Southeast Asia. I don't think there's a perfect solution to this. There's no perfect answer, but I think again we need to innovate. We need to have technologies. We need to have alternatives which are feasible, which are practical, which are economically viable. And try to raise awareness within the communities and build the economic case at household level that these practices can protect health of the individuals and also are economically viable and can protect the earnings, the income of the households and the farming communities.
Yeah, thank you, Professor Sotiris. Now I'll have some information also to Dr. Shukla. Shukla ji, can you also just highlight whether economic conditions of the farmers are the root cause of not happening technological intervention in reducing the stubble burning?
Yes, Professor. Actually, as I mentioned earlier in the opening remarks, that economic condition, especially of poor and marginal farmers who have very small land holding, for them, the experience shows that it was very difficult as far as affordability of the and paying affordability of purchasing these machines, which have been prescribed for management of crop residue, and even to pay the rent from custom hiring centers. So this was identified one of the problem for not effectively utilizing these machines in past few years. So what government has done this time that they have now these small farmers need not pay any rental for using these machines from hiring. So this new thing has been done, and subsidies have also been extended to machines for balers, because either you utilize the stubble in situ mechanism and within field or remove it. So mechanism should be efficient, and like decomposer, etc. They have to be used along with the in situ mechanism. They are not going to be used separately. So they will be supporting this process of in situ management of it. And as far as ex situ is concerned, now some market mechanism has to be developed, either by adopting some commercially viable solutions. I came across one fellow who has developed recently bio-packaging material, which will be replacing this thermocone. So he'll be using biotechnological process. Though there are a lot of hindrances, people are not adopting it, but certain market forces are working now. And RBI has also now put this CNG projects under priority lending mechanism. So financial instruments are also being used. So I'm quite hopeful that with this comprehensive approach, this issue is going to be resolved gradually. It will take time because people adaptability of these things and processes take little time. One more thing I would like to highlight here, because this problem is mainly related with the rice extra management, rice extra burning. So rice, if crop diversification is an important issue, because Punjab traditionally growing rice where there is a water problem also in that region, because that is another important factor which is being thought of, why not to diversify. And this problem is mainly associated with non-basmati rice straw, because basmati rice straw has less silica and that can be recycled. But non-basmati and which is used, that is 60% of the total production. So this diversification of crop is also important. But I agree that the economic condition of farmer is a very important issue, and some support is being given in terms of subsidy as well as rental, etc., putting various mechanisms there. But still a lot more need to be done. Thank you.
So I have an interesting question to Prashant. You're looking at, you also started recently the citizen science project and your previous experience. How this awareness about the impact, health issues, and also the technological benefits these farmers can get hold in addressing this, stubble burning related issues. In fact, this also been highlighted by Dr. Vera. She also indicated that if you increase the awareness, even in changing the, the crop pattern, making more incentive to the economic aspect. So whether these kind of things, do you think will be, useful in addressing this issue? Over to Prashant.
Thank you very much, Siva. In fact, I was about to mention this, so you picked up my brain actually on that. I guess the one of the major kind of hindrances I see is that the discussions that happens on the top levels, including like what we are talking here, they rarely are disseminated or reach actually to the people who are actually either doing this or suffering from this. So this is where the link of the awareness and the citizen science basically comes in comes into play. And the fact is that this is created by a lot of people, and if the very same people are managing it, then it will be more manageable than one person, which could be the government or the regulatory authorities actually doing it for everyone. So I think the one of the issues is, like, if you go to the rural areas, they hardly see that as a problem. For them, it's not a problem at all. They hardly understand that the air pollution, which they are causing, might be affecting somebody actually who is not, in their near vicinity. They hardly understand that whether these emissions which are coming and when they're doing this activity will be affecting them. So I think there is a very kind of a strong need, I would say, to empower the people to enhance their understanding, first of all, that this is not a good practice. Secondly, giving them the options, because this is another big problem. We say that, this is good or this is bad, but we really don't tell them what else to do. But of course, as mentioned earlier, this is an evolving field. So we don't have the solid, the technological kind of, the solutions, but there are things actually which can be managed. So in terms of if the burning has to be done, then could it be done actually in a way that it is the least detrimental? If there are no other solutions. So for example, most of the emissions actually they come through, there are different phases of the burning. So one is the smoldering, then the flaming, and so the most emissions comes actually when the burning is incomplete. So the fact is that whether it could be done in such a way, if this has been done actually, then it can reduce actually the emissions. Could it be recycled, as I said earlier as well, in terms of could it be used as a resource rather than using as a burden actually on them to clear out their field? Could it could there be other the technological measures like we have been talking about here that could be implemented successfully without costing money to the people? So the one major thing here is that no farmer would like to spend a penny actually on getting rid of that the waste material. In fact, they would love to have something coming to them rather than they paying it to get rid of it, because they see that it's a easy thing for them to burn it and get rid of it. So all these connections actually they can be made by using that the empowering approach with the citizen science, where there is a linkage actually with the research, with the policies or the regulatory authorities, with the people. And I see that as a major hindrance to this problem. So there is definitely a quite a big role actually to play of this activity. And this is where we could possibly emphasize as well, if there is a way to take this voice actually further out of this platform.
Yeah, maybe if Tagi sir is still there, would you like to comment on, because you have seen over the years how the things have been changed, whether the interventions what we have made. Do you see some light of the end of the tunnel, or do we need to work more in order to improve the socio-economic conditions of the farmer as well as the health quality of the life in the cities? Anju, there's some connection issue.
Am I audible now?
Yes, sir. You are audible.
My surname tells that I have link with the people who live in villages. The thing is that a farmer has his own notions and beliefs, and they are hard because they have come to him through generations. And it is not easy to convince him, because you're being very highly educated, coming from ICAR, etc., does not convince him, because he thinks that you are not really conversant with the local field conditions. That is his belief, right or wrong. So therefore, awareness is a very short step in the right direction. It does not achieve anything. He may be aware, but he will not proceed further. He will proceed further if he finds advantages out of it. Advantage can be in terms of money to begin with, in terms of convenience, in terms of time saved in a particular process, and in terms of assuredness that he is safe from other new problems. As I said, that all solutions bring new problems. So that is the area where a lot of work has to be done. And we have to learn how to converse with them. A visit, 1 hour conversation and coming back to headquarters really does not have any effect. I also find that there is still a lot to do in this area, because this particular thing which can digest the stubble can also have other biochemical effects. And so it's just a beginning, not the end of a research.
Okay, so thank you very much. So now our last question, since you are already there on the mic. So we will move on to the other panelists. So what is the way forward? Like, stubble burning is an issue. So if would you like to say we would like to face the similar problem in the next year, what is the way forward you think?
Rather than trying the same step after 11 months, there should be a lot of research done in the meantime, because this material can be collected and be available in the laboratory with soil and everything, so that all the pitfalls could be studied, and it should be possible to demonstrate with the help of videos and opinions of farmers, not opinions of experts, opinions of farmers to whom these demonstrations have been done. And that will have effect. I have great hope that this particular method, which is fast, which does not require removal of the stubble from the field, has great promise. But caution, I will again repeat.
Thank you very much. So kind of you. Now I'll move the same question to Professor Kim Oanh. So what is the way forward? Because based on your experience, what is the way forward for addressing the stubble burning issues in Asian countries?
Very, very challenging question to me, right?
No, the same question I asked to Professor Tyagi also. He has nicely said, so I'm looking from you now.
Okay, so I am so learning from your own viewpoints, but I learned that, for example, someone like Marcus Armand told me that their business model in Brazil, that they now successfully actually deal with rice-straw clean burning activity, meaning they only turn it into some value. But then I'm still looking for that. But to me, actually, to deal with farmer, you need to, of course, raise awareness, I mentioned again, but the way to give some incentives in terms of jobs creation, like mushroom growing or producing some value product like pellets, use it for cooking and bring them some money, some incentive should be there. And then awareness raising, and then at the same time, the authority also need to look into the option, not only ban, but also encouraging them somehow. Or sometimes we also should ban during certain period when already very polluted. And additional burning would get very high pollution level. So ban may be not totally, but should be in certain period we should like reduce urban burning. So that like in Thailand earlier in northern part, so they also ban burning during a month. But then of course it would turn out that it's more burning in the coming months. But at least in the peak period, we can actually have lower emission load from open burning. But then still there's some business model. Perhaps we need to look into that. And I'm not sure to talk about happy seeder. I thought that it's very successful in India in terms of like, look at the light at the end of the tunnel. It's something already happening and it worked well. Should just say we also should learn from India example of happy seeder, for example. So you are smiling. Is it really successful or not?
Okay.
Okay, so of course we need to somehow ask farmers to change their mindset, and it's not only to like a professor come and talk to them. They don't listen to us. It needs to be some way to work with them, to live with them, to work with them, and understand their need, understand their mind in order to have some change. But I mentioned that I heard from Marcus Armand that this is model and successfully in Brazil. So we perhaps need to look into that too. Thank you.
Thank you, Professor Kim. Now I'll move on to Professor Sartorius. So what is the way forward to address the stubble burning issues?
Thank you. I think Professor Kim and Dr. Tyagi made a very good point that what we need is engagement, long-term engagement with the farmers, with the communities, not just scientists and disseminating information. We need more than that. And we talked previously about awareness raising, but what we really need, I think, it's the long-term deep engagement with the sector, and using local champions, local farmers, people who are trusted by the communities to communicate and engage and listen to the farmers and their needs and their concerns. So I think we have obviously the technology. There are technological solutions. Some of them still emerging. They need more testing, perhaps, but what is absolutely essential is to have effective and sustained engagement with the local communities. Thank you.
Thank you very much, Professor Doris. So now I'll move on to Dr. Shuklaji. So what's your view on the way forward for addressing this stubble burning issues in next year?
So 2-3 quick points. The first is already government has spent a lot of money in providing these machines to farmers and custom hiring center. So these should be efficiently utilized, and whatever the problems are there, so it should be studied and problems should be removed, because a lot of good amount of funds, 1151 crore last year and 600 this year. So around roughly 2,000 crores are being spent for these machines. So they should be efficiently utilized, because ultimately they are also precious resources to be utilized. Number 2, as I mentioned, diversification of crop, because Punjab cannot depend upon paddy. Earlier times are different. It is high water consuming crop. So certain kind of mechanism or financial interventions may be required to promote other crops also for diversification. And technology like these decomposition technologies and other technologies which can remove the stubble if farmer prefer that. Like bio-CNG. Haryana has done a good work in promoting bio-CNG plants. So similar plants can be put up with the financial assistance by government. These 3, and lastly and most importantly, talking to farmers, what they want and how government can support them, because unless they adopt these technologies, it will be difficult to achieve. So these are the important points.
Thank you, Professor Dr. Shuklaji. Now I'll move on to Prashant. I hope UK is not facing this stubble burning issues, but what's your way forward views to manage stubble burning issues in the next year?
I think I would think of the different layers actually. So because there is one solution will never fit actually to all these issues. The number one, I will re-emphasize actually the fact of communicating the problem to the people who are basically the farmers, but not only communicating but also providing them the pros and cons and the possible solutions to it, so that they are empowered actually with the knowledge. So this is, I see that as a very important step. Then on the research side, I see a series of things actually which needs to be done. So for example, I'm advocating this for many years actually, this issue of stubble burning, this pollution episodes. It only highlighted in winters. I never saw this thing being in the month of May, having this kind of seminars or webinars or the news items actually which are mentioning that the burning is an issue. So one of the things is that this research is not just like you do it during the winters and then finish it. It has to be a year-long effort until you reach to a point where there are solutions there. Then it comes into the solution side of things. So the one is the technological solutions. So what we have, if that can be effectively used, that's great. But then one important area I see is converting that waste actually into a resource, which I again re-emphasize. Because the one thing which has worked really well actually, if you look at the rural communities, the recycling almost everything. And this is one of the things actually which has not been recycled to a great extent. Although there is a lot of things recycled for the fooder and the other activities, but not really this thing, because it kind of comes in a episode for example, it happens, in a very quick succession, and then this needs to be get rid of, very quickly actually from the ground, because the farmers are preparing their lands actually for the next, the crop. So I think, and I don't see that as a major challenge, honestly speaking, because this is a very nice fibrous material which could go into the building, these cardboards and jutes and so on. It only needs, I think, a little bit of efforts actually in that direction, which can link actually this into something useful resource. So I presume that you can keep talking, but I would stick with these 3 key points actually, just to summarize. The one is empowering people with the information and the solutions. Number 2 is implementing the technological solutions what we have to the extent actually they should be. And the third is converting this waste actually into a resource.
Thank you, Prashant. We have one scientist who also worked in Central Pollution Control Board. Dr. Shah is here, and I just would like to see his comments on stubble burning, because he might have already experienced several of such occasions. Dr. Shah, would you like to have some comments on the way forward for addressing the stubble burning issues in particularly in Delhi?
Thank you, Professor. Thank you for giving me the opportunity. In fact, I whenever the served CPCB for a long time, and whatever has been discussed today, I'm sorry. The same thing, it was repeated 3 years back also, and making alcohol, making manure, making power, so the same thing. We are not progressing other than use of the stubble, what Mr. Prashant has said, that it is a resource for us, and the use of this material in situ management is the solution. We know all of it. We know everything, but still we are not really focusing on the issue. We are going to everywhere. What is the impact? What is the smoke? What is the health impact? What are the areas covered? I'm really astonished. Stubble is burned everywhere in the globe. Yeah, everywhere. Just come here. But the thing is that in because you have asked for the Punjab and Haryana, stubble is burned everywhere. And 70% agricultural waste is burned across the globe. 40% comes only from the rice. Among these 30%, 20% contains that silicate. And silicate cannot be used as a food for the cattle. That is the problem. And the window for utilization is very limited. And we are having a mindset with the farmers, irrespective of rich, poor, moderate, nothing, no issue. They are having a mindset that we have to, because they are in hurry. What my chairman has told, there is insecureness. Whether my field will be, they will be able to vacate it within that 20 days or window or not. Insecurity is there. And that's why scientists has to ensure that that can be decomposed and converted into manure within 20 days. And that's why only we need is the agricultural scientists. They should come forward, and it is the solution with them only. Professor Dr. Tyagi Sahab is already told. They have already developed, they have broken the ice. Now it is now the matter of preparing that enzyme in a larger scale and application, and ensure that it is possible to do it. One focus, 1 point, 1 gain, sir. Let us not divert ourselves. We are listening and listening the same story. Same thing is being told to all, the problem, the maneuver. But Prashant has rightly said, I'm really happy. I do not know whether we are from same school or not. We have failed miserably in our waste management because we have failed to add economic value to it. all the advanced countries, they are earning money out of this waste. Every individual household, they are earning money, but we are not able to do it. Yeah, that is important. So only preparing those things into resource and converting them into manure so that they will get economic value also, and the confidence is required to be carried out. Thank you.
Thank you very much for the insight. Again, to re-emphasizing, all the panelists have been indicated that so there is a hope, and hope is to engage the farmers, as Professor Kim also indicated. It's as we go and talk to them, they won't listen. Maybe probably we will need to local community to participate, the local chairman or local person to help, which has been also highlighted by Satoris and also Dr. Shukla and Prashant. So I think this was a very good, insight into addressing this stubble burning problem. Now I'll hand over to Dr. Madhusudan to conclude this particular things. And Dr. Madhusudan is a advisor for CEPHA network, and he's also working with IIT Madras. So now I'll hand over to Dr. Madhusudan. So on behalf of CEPHA network and IIT Madras, I would like to thank all the panelists, to everybody to taking their time, and also participants, because you asked very interesting questions to make it the discussion much more useful, fruitful, to address the problem. So as we all, moving forward, we will try to learn some new things, as Tagi sir has clearly indicated. It's a life cycle. So we will learn and learn and learn. So we will keep learning and see that when what we learn is useful to the society. So now I'll hand over to Dr. Madhusudan.
Madhu, if you please permit, just 30 seconds. Kim, do you remember me?
Hey, definitely,
Yes.
Please.
Kim, we work together, Kim.
Yes.
Are you there listening to me?
Yeah.
Good opportunity to meet you after a long pause. Thank you. We'll talk to you later. Bye.
Dr. Professor Kim Oanh, would you like to say something? Yeah, please.
Oh, actually, I would like to thank everyone, and it's very good to participate and learn from you all, from panelists too. So thank you very much.
Okay, maybe just we will move on to the Professor Satoris. Would you like to say something? Then let's.
Just to thank everybody for participating. I think it's a great initiative by the network, the Clean Environment and Planetary Health, which is an engagement network. So that's very much what we are doing: engage with the stakeholders, engage with the key researchers, and also with the broader audience. So I think that's a great example of what CEPHA is doing in this space. Thanks very much for organizing this, and thank everybody for participating.
Dr.
Shuklaji.
Thank you, Professor Nagendra, and everyone who participated. So thanks once again for organizing.
Dr. Prashant, Professor Prashant.
Again, I would like to thank you and the colleagues actually for organizing this. And this is really a very useful and interesting platform. The only thing I would like, again, as I usually do, is try to take these findings and penetrate actually into where they can be utilized in one way or another. So it just doesn't remain just a discussion. At least some bits actually are going out where it can really help actually the people who are working at the ground level.
Yeah, thank you very much. So I just thought before we'll go, can we all just start our camera and take one photograph? Because see, this is the pandemic time. We will also see some happy faces and put it in Facebook and keep it more publicized to engage them. To all of you, I request start your video. Anju, could you please take a photograph, and then I'll hand over to Dr. Madhu to summarize.
Yes.
So all of you just take a photograph, start your camera. Anju, just indicate if you, you captured everybody. Anju, are you hearing me?
Yes, yes. Some of the people are turning on their videos.
Just you request them, everybody. Could you please, all of you, just turn your video?
So we'll wait for 1 more minute so then everybody can turn.
Yeah, I think we'll wait.
Okay, so I can hear the sound. So you've taken the photograph. Okay, so we will going to share, and in fact, we have created a CEPHA network, and definitely we will going to learn, and as a academicians, so we will try to learn from new things and see that how we can translate this to the younger minds and make it more useful to the community. So now I'll hand over to Dr. Madhusudan.
Professor Sir, thank you. Dhanyavad. Bahut.
Thank you.
Yeah, once again, welcome everybody. Today we started our panel, our discussion, that is the second monthly lecture series with Kim Oanh. She was explaining about the practices and the mitigation measures usually taking place in Thailand and the Asia Pacific region, and which followed by the panel discussion with the eminent panelists, as well as the we were very happy and we were blessed by the presence of former chairman Professor P.C. Tyagi, and also the former scientist from Central Pollution Control Board, and also we could see very young minds, those who are actively participated in our poll, so that we could get a clearly a division of poll from all of you. We once again thank for active participation. And the CEPHA network, we have a provision, and we always communicate what we discuss to the authorities and also the regulatory agencies, so that whatever we discuss in the academia level, it will transform or it will reach to the regulatory authorities. So this we will be doing it. Earlier also we have done it, and this time we definitely will be doing it. And once again, we thank all the panelists, and especially our leading speaker, Madam Professor Kim Oanh, for joining for this month's lecture series. Thank you once again. Thank you.
Yeah, thanks all. And Anju would like to say, and I would like to thank all the team members. Anju is a network manager who has also worked day and night to make it these things to happen, and she's coordinating all these activities. So thank you very much, Anju.
Thank you, Professor. Thank you all.
Network, so we'd like to thank you. So thank you all. Enjoy a great evening. Thank you all, and see you next monthly lecture series. We will announce it. And in fact, we were organizing a conference in the December. So 9th to 11th, and details are available. So if you type on IICAQM, so you will get more details. So please join us in the next conference. There are several invited lectures, and many of our panelists will also going to speak about different topics. So please join us there. Okay. So thank you very much. So see you all.
Thank you. Thank you, Professor.
Bye bye. Gupta ji, thank you very much. So see you. Nice to see you.
Thank you, sir. Thank you.
Okay, so Anju, you can close the meeting, and then you can see. So I can happy to see some prints here. Okay, so they're all participating. Very nice. Okay, Madhusudan sir. Anju, can you stop recording?
Yes, sir. I am stopped.